Mathematics is full of puzzles and mysteries. Some are easy to solve, like a simple jigsaw puzzle, but some are very, very hard. The Collatz conjecture is one such mystery. It looks simple, but it has baffled mathematicians for nearly 100 years. Imagine a game with numbers. You start with any whole number you like. The rules are simple, but the outcome is a mystery. Let us play this game and see what makes it so interesting. The rules of the Collatz conjecture are easy to understand. This mathematical puzzle has fascinated both amateur and professional mathematicians for decades. Despite its simplicity, it remains unsolved and continues to intrigue those who delve into its depths. If the number is even, divide it by 2. This step is straightforward and follows basic arithmetic principles that we all learn in school. If the number is odd, multiply it by 3 and add 1. This step introduces a bit more complexity, but it's still easy to follow. That's it. Let's take an example to see how these rules play out in practice. Let's start with the number 6. This number is a good starting point because it allows us to see both rules in action. 6 is even, so we divide by 2. 6 divided by 2 equals 3. This is a simple division that gives us a new number to work with. Now we have 3, which is odd. This means we need to apply the second rule, so we multiply by 3 and add 1. 3 times 3 plus 1 equals 10. This step transforms our number into a larger one. Now we have 10, which is even. We go back to the first rule. So we divide by 2. 10 divided by 2 equals 5. And so on. This process continues, alternating between the two rules. You can try this with any number. The sequence of operations will vary, but the rules remain the same. The surprising thing is, no matter what number you start with, you always seem to end up at 1. This is the mystery and beauty of the Collatz conjecture. It's a simple yet profound puzzle that continues to challenge our understanding of mathematics. The big question is, does every number eventually reach 1? We don't know. This is the heart of the Collatz conjecture, a problem that has puzzled mathematicians for decades. Despite its simple premise, it remains unsolved. Mathematicians have tested this with countless numbers, even very big ones, and it seems to work. From small integers to numbers with many digits, the sequence always seems to end at 1, but we haven't found a way to prove it for every single number. The challenge lies in the infinite nature of numbers and the unpredictable behavior of the sequence. You might think, we've tested so many numbers, it must be true. However, in mathematics, empirical evidence isn't enough to establish a universal truth, but in mathematics, testing many examples isn't enough. We need a rigorous proof that can be applied to all numbers without exception. We need a solid proof that works for all numbers. This proof must be able to withstand scrutiny and be universally accepted by the mathematical community. And that's what makes the Collatz conjecture so difficult. It's a tantalizing mystery that continues to challenge and inspire mathematicians around the world. Section 4. Connections and implications. The Collatz conjecture might seem like a simple game, but it has deep connections to other areas of mathematics. Some mathematicians believe that understanding this conjecture could unlock new discoveries in number theory and computer science. Imagine if the conjecture turned out to be false. It would mean there are numbers out there that behave in completely unexpected ways. This would change our understanding of numbers and their properties. Section 5. The quest continues. The Collatz conjecture remains one of the biggest unsolved problems in mathematics. This simple yet perplexing problem has intrigued and baffled some of the greatest minds in the field. Despite its straightforward premise, the conjecture has resisted all attempts at a definitive proof. It's a puzzle that has fascinated mathematicians for generations. From the early days of its discovery to the present, countless hours have been spent trying to crack its code. The conjecture's allure lies in its simplicity and the profound implications it holds for number theory. Will we ever find a solution? This question lingers in the minds of both amateur and professional mathematicians alike. The quest for a solution is not just about finding an answer, but understanding the deeper truths of mathematics. The beauty of mathematics is that anyone can explore these questions. Whether you're a seasoned mathematician or a curious student, the Collatz conjecture invites you to dive into its mysteries. It's a universal challenge that transcends age, background, and expertise. You don't need to be a professional mathematician to be captivated by the Collatz conjecture. Its simplicity makes it accessible, while its complexity keeps you engaged. It's a perfect example of how mathematics can be both approachable and deeply challenging. Pick a number, any number, and see where it takes you. What do you think? The journey through the Collatz sequence can be a thrilling adventure, full of unexpected twists and turns. Each number holds a unique path, a story waiting to be discovered. Will we ever unravel the secrets of the Collatz conjecture? The pursuit of this enigmatic problem continues to inspire and challenge. It's a testament to the enduring spirit of mathematical inquiry and the endless quest for knowledge. Or will it remain a mystery for generations to come? Only time will tell. But one thing is certain, the Collatz conjecture will continue to captivate and inspire those who dare to explore its depths.